chance to talk multiple times, but I also know that it's not required for assignments. But it's full 1080.
That's like half the resolution of this.
Yeah, but this was really expensive. Maybe this is like another one. To say a bit about the impact that
I wasn't planning to. I can give a little spiel if you want.
I think this presentation works. It's up.
Yeah, sure. Yeah, I can start with that.
Okay. Good morning, everyone. Nice to have you here. So today will be the last guest lecture in this course. Today we have Benjamin Kelley here. Benjamin Ragan-Kelley. He's a researcher at Singular Research Laboratory, working on a project called what used to be called IPython Notebook, what is now called Jupyter Notebook, and he will tell us a lot about the project and how it changed also from IPython Notebook to Jupyter Notebook, what this actually means.
Yeah. Okay. Is that working? Are we good? Hello? Yeah, okay. Yeah, so I'm going to talk a bit about IPython and Jupyter and how they relate to each other and how they can be used to help you do your work, whether it's research or just doing your homework for assignment. It can be useful in helping you get that done. So I'll start, as Simon just mentioned to me, with a bit of a motivating. There's an alarm going off. There's an alarm somewhere else. It's not here, so that's okay. So just a bit of background about what these pieces are. Making sure we know our evacuation plan. Okay. All right. So at we have these two pieces of the Jupyter project. One is the notebook, which I'll be using to present what I'm going to talk about, which is this document format that contains text and images and rich content using a markup language called Markdown. And then you can also, because it's targeted at kind of scientific mathematical uses, we also support mathematics in LaTeX expression format using the JavaScript library MathJax. And so this right here with the logo and a bit of text is what we call a markdown cell. So if I edit it, I can double click on it, and then you can see there's some markdown here. So this is how you indicate a header in Markdown, and some links and an image, and then some mathematics, and then I can press Shift Enter to render that, and then you have this rich content with anything you can do in HTML. Ultimately, Markdown is really just shorthand for writing HTML. And with this document format that can also include code And then if I run this code, it can include the output of that code. And then this is a JSON. So this command that I just ran actually showed me the content of the file that I'm working in. It has this content of, so there's a cell in a JSON format, and this cell is a markdown cell. The second cell is a code cell that doesn't have any outputs because when I ran it, there weren't any. But if I save it and then run it again, it'll actually have some outputs. Because I'm actually showing you the contents of the file that I'm editing. And the coolest thing about this document format is that it means you've got a single document that can have some mathematical explanation, some prose describing what you did, why you're doing it, why you're talking about your results, and then it also has the code that you ran, and then it also has the results of the code that you ran in the form of images, graphs, interactive visualizations, or just regular stream output. And what's useful about this is that you can share these documents. So what Jupyter runs a service called NBViewer. So you take this JSON document that contains all the information about what you did, all the markdown, and then we run this service called NBViewer that you can point it at any notebook. So if I just open a new tab, I can go to nbviewer.jupyter.org, and then you can see kind of some links to notebooks, and there's this field where you can enter a URL for a notebook anywhere on the internet that's publicly accessible, or a GitHub repository. So, for instance, if I do, I have uploaded the notebook I'm looking at right now. To this URL, which I can visit. And then this is the same notebook I'm looking at, hosted now on the web. And this is just the rendered content. I can't actually run code with this, but it means that I can do my work in the notebook, and I can share that to anyone who has a web browser that can see my results and see what I've done. And then you can click the little down, someone who finds a notebook and say, oh, that's interesting, I see your results and what you did, maybe I want to play with that, change some things, so you can just download the notebook, and that'll download the actual original document, not the HTML render, and then they can edit the document and change it. And so one of the useful applications of this kind of work is in an area that generally referred to as reproducible research and reproducible science. So one of the cool, my training is in physics, plasma physics, and one of the cool results in physics recently is the LIGO gravitational wave observation. And the LIGO experiment, which was a very cool experiment using big lasers and things that measured very tiny oscillations in distortions in space. They published the actual data that they used to identify the signal, and then published notebooks that go through the analysis they did to say, this is the actual raw signal from our instrument, and then these are the steps we did to, claim our scientific result. And so they just published a notebook like this, the static HTML file that you can download and run if you want. But another aspect that of the way Jupyter works is there's a group running a service called Binder that lets you take any notebook on any repository of notebooks on GitHub and then actually get a server with a running notebook that you can actually rerun somebody else's code without installing anything, just on the web. And I can do a quick demo if it's working. My Binder's had some issues recently. So what I did was I downloaded the LIGO notebooks, and I cleaned them up a little bit. And then I created a binder, which may or may not work right now. And so what this does is I say, hey, Binder, I would like to take the notebooks that are in this GitHub repository and then give me a little server running with those notebooks and then some things I installed. And then I can actually run through the actual analysis that the LIGO physicists did to say, this was actually two black holes spiraling around each other and collapsing into one. So it's ready. And so this can be useful if in scientific work if you've got a computational result, you can not only say, this is the analysis I did and show people that, like you do in a normal paper. You can actually say, you don't have to believe me. You can actually see it. You can run it. You can change it. And if you're curious about how the model is sensitive to a particular parameter, you can just download it, run it, change the parameter, and actually see for yourself how things change. It says it's ready. Slowly. We can come back to that. I'll let that go for a bit. So I'm mostly going to talk about how IPython helps you learn what program you actually want to write. So in computational research, we spend a lot of time not actually knowing what code that we want to run. We don't know. We're still figuring out what we're trying to do. And in IPython, we aim to make that process more efficient, more effective, more pleasant by adding interactive features to the Python language. So Jupyter, which provides this notebook environment and these things, is actually language agnostic. You can use the notebook in about 40 or 50 different languages. But IPython is what we call a kernel for Jupyter. So when you want to run a Jupyter notebook in Python, you use IPython to do that. And IPython adds things to the Python language to make kind of figuring out interactive iteration on writing Python code more pleasant. So at the basic level, we've got some code, and we can run it. And you have output. Pretty straightforward. You get output as it's produced. So this is just going to produce some output over time and then wait a little bit in between. You can see that we don't have to wait until the block of code is done to see the results. And then the model that we use in IPython and Jupyter is what's called a REPL, a read eval print loop, REPL, and that means that it's not running a whole program in each cell. It's got a running program that stays running, and then each cell kind of adds to that program. So I was iterating through I, and now I can see what I was. So the variables you define in one cell are still available in other cells, and again, you can go back and change them. And so you don't have to, if you want to change a piece of your program, you don't have to go back and rerun the whole thing, which is important for this kind of iterative development of, I loaded my data, I computed my data, and then I want to do some analysis and plotting. You don't have to rerun all your computations before you change to make a little tweak in the plot that you end up with. You just need to rerun the plotting step. And so that's the basics of just interacting with Python. But what IPython does is it adds a few things to the language to make this even nicer. So a lot of IPython's poking around is signaled by the question mark. So if you want to get help about something, if you want to find out about something, it generally involves using a question mark in some way. And if you just start with, okay, what's going on? Tell me everything. If you just run a question mark, it tells you a bit about IPython, about how IPython works, what it does, where to learn more information, and the various things that IPython adds to Python. But more often, the question mark you use on an object. So when you run with a question mark, so let's say I've imported the collections module from the standard library, which defines a bunch of things, and I can put a question mark on the named tuple, and that tells me a bit about what named tuples are. So I can see the signature. So this is probably the thing that you should take away from the most is I need to call something. I want to know how to call it. I'll run question mark first. And then you get a really quick view of, okay, these are the arguments that this thing takes. And then this is the doc string, hopefully, that tells you about what it does, how it works, maybe explains the arguments if their names aren't clear enough. And so this is what you spend a lot of time. I know I want to use NumPy. I want to use NumPy to solve some linear system. I don't know which is the right-hand side, which is the left-hand side, use question mark, and it'll tell you what the arguments are, what they mean. And so you don't have to spend as much time going back and forth to the big, deep documentation that explains every detail about it. You can just say, okay, how do I call this? Now I know. Now I can call it, and kind of keep moving through that process. And now often, maybe this information isn't clear, or you've got a function that doesn't explain itself well enough, or you think you understand from the brief explanation, but it doesn't seem to behave how you'd expect. The next step is 2 question marks that you're really serious about. You want to know what's going on. And what 2 question marks does is, if available, it actually loads the source code for what you're inspecting. So if you want to see, okay, how does this work? What does it do? The docstring wasn't good enough. Or the docstring said something that doesn't appear to be true. So you can look at it, peek in. And so what is it? We're looking at the counter type, which is an object for counting things. And you can see it's actually a subclass of a dictionary. And you can see that it's got these this update method. It's got methods like most common, elements, and then we can see how they work, and you can use that either for figuring out why it's not doing what you expect, or you can use it for inspiration for other things. So I can instantiate a counter, and I can look at it. So I see I've got it. If I just give it a string of characters, I've got a dictionary where each key is one of the characters in that string, and then each value in that dictionary is the number of times that element, that character appeared in the string. The next thing we do with question mark is we add asterisk or star to search. So this, what it does is a wildcard search. So anything in the namespace that you can that contains that string with any wildcard matches. So you say, I know I want to do something with an array in NumPy. I don't remember how. I just remember it has something to do with arrays. So then you can say, okay, NumPy, tell me all the things you can do with arrays. Just by name. Let me see if that can actually help me figure out what it is. And then the next thing for just refreshing your memory on what IPython can do, or finding new things, you can run this %quick_ref, which gives you a little quick summary of kind of common things people do with IPython, things that are useful to remind you what you can do. And then the next major poking around is tab completion. So when you have an object, so say in this case the collections module, and you want to get an attribute, this can be used both for discovery, but it can also be used just to save you some time for typing. So if I press tab here, it shows me all the attributes that collections have. And if I do start typing counter and there's only one match, I can press tab and I'll just finish typing. So this is common in text editors, IDEs. It's a useful thing for just being, on one hand, just efficiently typing, so you don't have to type all the characters, and then on the other hand, it can be useful for kind of poking around and saying, what is available to me? I know I want to use this, but I don't know, maybe I don't know which method to call, and so we can do a similar exploration for array. We can poke around modules to see what's available. And so maybe I'm curious about array to string, and then I can see how to call it. I call it with an array, and then some stuff, and this is a function that returns a string representation of an array. Next step is that's useful, especially, so I'm using IPython in a notebook, but you can also use IPython in a terminal. So all the things that I'm doing right now, I can also do just at a regular terminal and type IPython. And I can do my tab completion, my searching. So when you run some code, you can see that these prompts, there's input 15, and output 15. These record, every time you run some code, IPython records what you ran and the result of that. And you can access those. So in IPython, just like in regular Python, you can access the most recent result with underscore. This is especially useful if you just did something expensive that took a while, and then you realize you need a handle on that result, but you didn't assign it to a variable. IPython assigned it to a variable for you. It's called underscore. So you can say, oh, I actually want, let me get that most recent result. And that's accessible as the variable called underscore, and it's always the most recent result. So if I run this again, each time I run it, it's getting the most recent result, which is the same cell again. And then little useful things like if something's producing output that you don't actually want to see, you can put a little semicolon on the end, and it won't. It'll suppress that output if something returns a result that you don't care about and its presence is somehow offensive to you. You can suppress it with a semicolon. That also suppresses the output cache. So the previous result is the previous result that was actually displayed, not the result of the suppressed output. Let's use 15. And so you see the reason these look like Python list or dictionary access. So it's out bracket 21 and out bracket 15. Out 15, so you don't just have this underscore, you can actually get the output there's a variable that IPython injects called out. And so if you have some result up there that you want to get a handle on that you lost, you can just say, all right, give me output 15. And then you can do work with that. And you also do these with underscores for historical reasons. And then if you want to look at kind of what's the most recent code I ran, or this also works for searching your history, not just in the current session, but forever. You can use this history command to show me the first 5 commands I ran in this kernel. And then you can use question mark to say, all right, what can history do? Right, so history can show me lines from the current session, and it can also, it can save your history to a file. It can search through your whole history. Say, I know there's a plot command that was really complicated that I need to use again. I don't remember where I did it. IPython remembers. If you can remember a little thing about it, you can use history-g to search with a right expression for some code that you ran sometime in the past. So IPython maintains a database of all the commands that you run, and you can search that database with the history magic. The next thing that IPython does to help your interactive use is interacting with the underlying system. So one of the things that Python, the language, isn't great at is being concise and expressive at system calls. So if you're used to a shell like bash or something like, or other terminal, navigating the file system is really quick and efficient. You do CD and ls. You just need a character or two to do these simple operations. In Python, that's like os.change directory and os.make-dirs and os.system, or you actually shouldn't use os.system really. Subprocess.popen, which is even more verbose and annoying. So if you want to call out to the system, it can be a bit tedious to do that in Python, and that's usually okay for Python programs because you don't need to be doing those things that often, and a little verbosity is not a big deal in a big program. But for interactive use, you often want to ask questions like, all right, where am I? I've lost track. Show me the current working directory. Show me the files in here, that kind of thing. And so the next thing that IPython adds to the language, so after question mark for poking around, we've got exclamation point. So if you start a line with exclamation point, that'll be a system call. So just like, so pwd is a shell command that prints the current working directory. ls is a shell command for listing files. And so you get all the efficiency of regular shell commands but you get them in Python just by adding this exclamation point. So this is actually an extension to the language, the Python language that IPython gives you. And that exclamation point is actually optional by default, so if you start lines for certain things. And you can store the results of these operations in objects, so you can do equals bang ls. So now I've got a list of the lines of that output. So I can quickly run a shell command, and then I have a Python variable that stores the output of that shell command that I can work with. And it goes the other way too. So just like I had, I took a shell command and then stored that in a Python variable, I can use Python variables to build my shell commands. So if you use a $, that will take my Python variable files and then build that into the string that I actually use in the shell command. And so this lets you do kind of efficient scripting of in kind of this meta Python language. And then if you put full expressions inside braces, this is based on something called Python fancy string formatting. Inside braces, any expression, so it can be a bit of Python code, in this case getting the first item from files and then uppercasing it, and then it builds that as the argument that's passed to the shell command. And these don't need to be dedicated to whole lines, so these can happen to whole cells, so you can run these in loops and everything. So in this case, I'm doing some simple loop through my files, and then I'm running a command with some fancy string formatting on those files, showing me the notebooks in the current working directory, and then little dashes for all the files that are notebooks. And the reason this works is because Python, while it extends the language, the main thing it does is when you give it some text to run, IPython says, okay, this line starts with a bang. With that, all of these extensions to the language actually correspond to just regular Python function calls. And so what IPython does is it takes the block of text, notices the little IPython bits, and then turns those into pure Python function calls just in place. And then it runs the Python, the actual Python code. You can actually see that. If I remember correctly. So this is actually the Python code that ran. So it turned the bang into get IPython.system. Right, that's all it did. And now this is a pure Python function. And then this method on the IPython object handles the translation of the arguments. And so the next biggest and kind of an area where there's lots of room for cool things to talk about is the major extension to the Python language called magics. And magics, which is history is a magic, are these lines that start with a percent symbol, and these are Python functions that are designed to take the rest of the line as an argument and then interpret it as kind of this shell style syntax that's more convenient and pleasant to type in an interactive context. So time it, if a line starts with 1%, then it's what we call a line magic, where it takes the rest of the line as an argument and passes it to the magic. And time it is the magic I'm going to be using most of the rest of the time. And what it does is it takes a little block of code, and then it runs it a whole bunch of times, and then tells you something about how long it takes. And so this is really useful when you're profiling, figuring out how to make your code fast and efficient. You can say, okay, how long is this taking quickly? So time it is actually a module in this Python standard library, but it's rather complicated to use, or complicated, verbose. It takes a lot of typing to use the time it module. And in particular, you have to tell time it. So in this case, it says I ran it 10,000 times. each time I ran 3 samples and then took the best value. So I've got, I ran this little bit of code 30,000 times and then did some statistics to tell you, what, estimate how long it takes. And the time it module provides these things like run it this many times, but what it doesn't do is say, you have to tell it how many times it should run. And so one of the useful things that the time it magic does for you is it runs it once and then says, okay, this takes about a second, so I'm only going to run it 10 times. This takes about a nanosecond, I'm going to run it 1,000,000 times. And so it estimates how long it's going to take in order to pick the number of loops so that you don't accidentally run a loop that takes an hour or takes no time at all. So if we give it a few values, and in this case we did 2% is what we call cell magic. So single percent takes the rest of the line, 2% takes the entire cell and passes it to the magic. So in this case, if the thing you want to time is actually more than just one line, you can pass it a whole cell. So I just did a couple examples. And just like exclamation point, you can use this inside code blocks. So I'm just going to iterate through a few sizes and then see what time it does. And these will take a few seconds. And the key here is that as it takes longer, time it will run fewer loops so that it doesn't take forever. Right? So 100 it did it 1,000,000 times, and then 200 through 400 it did it 100,000 times. Am I reading the right numbers here? Yeah. And so it's because once it starts taking longer, then time it will reduce that to fewer samples. And you can see kind of an obvious case of if I did time it just a sleep that takes, so the way it measures is if you do something that takes a pretty long time, then it will run it at a much smaller number of loops in this case. If it takes 1/10 of a second, it'll run it 10 times, and then you can also tell time it takes arguments. So if we ask time it, what can you do? You can say, okay, you can, if you don't want time it to guess, you can pass it the number of loops and the number of repetitions. If it's picking a too small a number, you can say, please pick a bigger number. And so the important thing is that so time it magic actually takes a block of text and interprets it as Python code, which is kind of like a normal cell execution. But the important thing is that these magics are Python functions that just take an argument that's a string, and they're allowed to do whatever they want. And so you can write a magic that says, okay, I want a block of text, and I want to actually run that on a remote server. I want to take this block of text and translate it from English to Norwegian. It can do anything. And one of the examples of that is this bash magic takes the block of text and then runs it in a bash shell. And then Ruby runs it in a Ruby shell. Write file takes the line with a file name, and then it writes the rest of the cell to that file. Right, so with cell magics, you get the line as one argument, and then you get the body of the cell as another argument, and you can do anything you want with that. And then, of course, there's a magic called ls magic that tells you what all the magics are. So if you want to see, okay, what magics do I have available, I can look around and say, okay, what does rerun do? I can say rerun, question mark. Reruns the previous input. So like you ran something, you just want to run it again. I actually did not know that. I thought there's something I was fine. I've been working on this for 10 years, and I didn't know we had rerun. If you're getting code from documentation, so often Sphinx Python projects often use Sphinx for documentation, and they'll have code blocks that have these little prompts on the front that look like interactive sessions. Or if you've got code from an IPython session, it'll have those little prompts, and you copy those. Those can be kind of annoying to strip the all the prefixes off. IPython recognizes those and ignores them, so I can run this, which is totally not valid Python code. But IPython says, oh, you're copying and pasting from a terminal or something. Don't worry about it. I'll deal with it. I can recognize the prompts and ignore those. Yep. There's some async output. So I've written a module that I'm calling mod with my write file magic. And this just divides 1 over x minus 1 and then calls that with g. And if I call that with 0, I get this 0 division error. So one of the things that IPython does over the standard Python module is it gets you these syntax highlighted tracebacks that makes it a little bit easier to parse and find where the important information is. If for some reason this isn't enough information, there's a magic called X mode that gives you a more verbose exception reporting mode. And then if I run the same command again, it says, okay, when I call mod g, tell me what mod g is. When I call f, tell me what f is, what y is. So it actually shows you the variables in each stack frame. So you can see, okay, why did this do something weird? What was that value of that variable? But beyond that, when I ran that and I got the error, maybe I want to actually poke around more interactively. So you can run %debug, and now I've got a little prompt inside where the error happened. So this is something called post-mortem debugging. So it's something you can do for, I ran code, it hit an error, and I want to do some poking around with the state of that last error. So I can say, okay, what was x? Okay, x is 1. I can go up for up the stack frame. So I did g of 0, and g called f of 1, and then f did 1 over 1 minus 1. So I can go up. Now I'm inside g. I can say, okay, well, what was y when I called that? Okay, y was 0. Okay, what was f? Yeah. So with debug, you can poke around interactively to say, okay, well, that went wrong. I'm not quite sure why. One thing you can do is turn on more verbose exception reporting. Another thing you can do is enter interactive debugging to kind of poke around with what happened. And you can also just prompt if for some reason you want to run some code that gets asked for input. Like I've got a function that wants to run some things, and I just want to ask the user, okay, what should I do? So this is just asks using the standard input function. And then you get that back. So this is something that works in regular Python. The main thing here is that even that kind of stuff where you're asking, normally we'll be asking the terminal, it works all the way to the notebook. And then more cell magics with, I can run some Perl code, I can run some Ruby code. And then the last big thing for working in the notebook is, so I've just done simple code that produces little text output. Often you'll want to be plotting in the notebook, making graphs, looking at things. The primary library that you use for this in Python these days is Matplotlib. There are a lot more now. The main thing with Matplotlib is, so Matplotlib is this big fancy plotting library that's very powerful. And it has the notion of something called the backend, which are different rendering engines. And so you can do, and then the Matplotlib magic tells IPython to tell Matplotlib what backend to use and to hook up some event loop things. So if Matplotlib is using Qt, it needs to actually, IPython and Qt event loops need to talk to each other. And so this Matplotlib magic selects the Matplotlib backend and hooks up any GUI event loop things if needed. And I've chosen inline, which just takes images that Matplotlib produces and then puts them inline in my notebook. So if I run a simple plot, then I just get that image right here. And there are many other plotting libraries that have more emphasis on, say, interactive visualization in the notebook. One of them is called Bokeh. One of them, there's a new one called Altair. There's a lot of, there's a growing number of visualization tools that work in the notebook with varying degrees of interactivity. Maplab is focused more on production, like publication quality figures, whereas others are more focused on more interactive stuff. And so you can pick your plotting tool based on kind of what you actually want to do with your data. And then the last bit is something called widgets. So we've seen things that produce output, basic static output. Widgets let you put things in the notebook that are actually interactive controls. So in this case, we have this interact thing, which is a Python decorator. So if I decorate this function with interact, it gives me these controls for all the arguments. So I said, I've defined a function with, num is a number, text is a string, check is a Boolean, and then what I get is a slider that I can, and as I move the slider, you can see the function gets called and actually prints the local variables in the scope of the function. So every time I move the slider, the function gets called again. And you can uncheck the box. And what interact does is it looks at the arguments and says, okay, that's an integer. I'm going to guess that you want a slider for that integer. It says that's a string. I'm going to guess you want a text box for that string. It says that's a Boolean. I'm going to give you a checkbox. And then whenever those things change, then whenever you change one of those controls, it calls that function again with the current value. And you can do some really, I'm not going to get into it, but there are some really powerful things you can do with widgets. It's not just interact. You can build the widgets manually and hook up the change events to arbitrary Python functions. The key is that widgets give you things you interact with on the page whose changes are reflected in the Python code in your kernel. Yeah?
You need to have a default value here because otherwise you don't know the type.
Yeah, so if I did this, so first argument's not optional. It said, I don't know what to do with num. But you can also tell interact and say num what that should be. So it doesn't have to be in the function. It can be you can give that information directly to interact, and it can also be things like Couldn't
you use tag hinted from 3.5?
Yes. So in Python 3.5, there's something called function annotations, and you can use. I'm going to. Yeah, so if you put that information in the function annotation, so this is not a default value, it is a little note that function annotations are a place to put little notes for people using your functions, and interact actually looks at those notes and says, okay, you told me there's a 5 here, so I'm going to use that information, and you can put things like 5, 10. So now it's a range. If you give it two integers, and this wouldn't work in if I give it as a default value. But if I did num equals a tuple, oh, it does work. That shouldn't work because that doesn't make any sense. But with a function annotation, you can use these what we call widget abbreviations. So there are a few ways that you can, with shorthand, give interact a hint about what widget do I want. And so if you give it 2 or 3 numbers, it's going to interpret those as a range for a slider. So if you give it like 5, 10, it's going to be a slider from 5 to 10. If you give it 1, 10, 2, it's going to be a slider from 1 to 10 with a stride of 2, just like a range. And a dictionary will give you a drop-down chooser and things like that. So combining the display, so I showed we've seen text output and we've seen images. IPython can, or Jupyter and IPython can represent things not just as images or text. It can also be LaTeX mathematics. It can be interactive HTML and JavaScript. It can be SVGs, PDFs. You can produce output in a number of different formats, and the notebook will just pick the one it likes best, that it understands. So you can display an object, and then IPython sends every representation it knows how to make. So it'll send you a LaTeX representation, a PNG representation, and a plain text representation. And the notebook says, okay, I like the PNG best. And then it will display the PNG. And the reason we send more than one is that you can save the notebook. So in the interactive case, maybe I prefer HTML the best, because HTML is probably the most interactive output that I've got. And then you save that notebook, and then there was a PDF that the browser doesn't even understand how to present, because for a variety of reasons, or without a plugin anyway. But then we have another tool. That's how NB Viewer works, called NB Convert, that takes a notebook, the JSON notebook, and converts it to another format. And those formats can be HTML, like NB Viewer produces. It can be restructured text for integration into your documentation. It can be Markdown for a blog post. It can be a PDF via LaTeX. And so if you're doing the LaTeX case, you don't want the HTML representation of a plot. You want the nice vector PDF version of the plot. So if you publish both, then the kernel produces the PDF and the PNG, let's say, sends those to the browser. The browser saves both, but shows you the PNG, and then when you put it through your LaTeX pipeline, it uses the PDF for the nice vector version. And this is part of why it's useful that we use this JSON representation. It's kind of this abstract structured document, because different versions of things can be useful in different contexts depending on where you're sending your notebook. And so SymPy is a library that's useful for symbolic computing in Python. And one of the things that SymPy provides is LaTeX representations of expressions. So here I've got x is a symbol, x. And then I tell SymPy to say, use MathJax for rendering LaTeX. And then when I display x, it looks like a fancy math x rather than a simple ASCII x. And where this becomes useful is once you've got real equations. So what I've done is I have a function that factors x to the n minus 1 and shows me on the left-hand side x to the n minus 1, and on the right-hand side shows me the factoring of it. And what this does is it just returns the SymPy equation object. But SymPy has told IPython, when you see an equation object, this is how you compute the LaTeX representation. And so now when I move the slider, it computes the factorization and then shows me this nice LaTeX mathematical representation of that equation. And because it's MathJax, I can look at, okay, that's very small. So this is the tech that MathJax showed me. Right, or I can view it as MathML, which is a web version of math, ways to write equations. And I think that it is 11 o'clock, which means I think time for a break.
We start in 15 minutes.